Hey guys, and welcome to this comparison video looking at ChatGPT versus DeepSeek. And the way I'm going to compare these, and this is all going to be me seeing the answers to these for the first time, I'm going to ask it to do some boilerplate code, solve a leak code question, and then try and explain some concepts. I put the prompts here that I'm going to use. I will do this one a bit differently because it's actually going to be returning code back, which I'm going to try and use. So it's going to be doing some boilerplate code first to make a simple GET request. So what I'm going to be doing is giving this here. So make a GET request to this site. This is a pretty cool resource where you can make requests to. And it's actually quite good to sort of test your skills using curl or using the requests library in Python. So with this copied, let's go ahead and try this first of all with ChatGPT. Let's see what we get here. Okay, yeah, so it's told us to use the request library, which is as I'd expect. Now let's go to DeepSeek. Let's see what happens here. Bear in mind, this is my first time seeing both of these as well. A little slower in DeepSeek, but there we go. Okay, yeah, they're pretty much the same, aren't they? So, let's take this guy here. Interestingly, ChatGPT just gave us a response without the comments. Look at that explanation. Ooh, okay. Right, let's try these both. So we'll head back into VS Code. We'll put this guy just down here. And then hitting run, that's absolutely fine. This does show my IP, so I'm not going to show the output, but yeah, that works absolutely no problem at all. Okay, now let's go and grab the one from DeepSeek. And there we go, let's grab this. And for this, I'm just going to compare the code. So I put this guy underneath. I mean, yeah, they're basically the same, aren't they? The only difference I've noticed that DeepSeek is doing is giving us the comments as well. So make a GET request to this URL, print the response content. And I particularly like this here. So if I just go back to this one, I mean, yeah, this does the job, but I suppose if I was kind of learning Python from scratch, I put this in here, I mean, this is pretty cool. Let's see. So this told me to do a pip install for requests. Let's see. Whereas, yeah, ChatGPT didn't. That's interesting. So this is kind of assuming I've got requests already installed, I guess. There's no kind of mention of installing it, whereas, yeah, look at this. This is saying if it's not installed, use it using pip. This is giving me an example of some output it'll do. I think even though the code is basically the same, I'm going to say DeepSeek wins for this one. Now let's step it up a notch, because what I want to do now is ask it to do some exception handling. So let's take in this next bit. DeepSeek, you can go first. So exception handling, here we go. Okay, and look at this. This is cool. So it's gone quite crazy, these exceptions, hasn't it? But this is good. Let's see what it's done. So it's first done this raise for status here. So if we get anything that's, in this case, 400 or above, which is indicated here, it's going to be like, yeah, okay, this is going to basically kick off. What else has it done? It's gone through the individual errors, which is quite nice. So HTTP, connection error, a timeout, or in this case here, this has gone for kind of any other generic request style exception, which is cool. I like this. This is really nice. Let's see if ChatGPT gives us anything sort of similar. Okay, here we go. We've got a try. That looks good. Same raise for status. And okay, it's jumping around a bit. Right, okay, this is a bit more straightforward, isn't it? So it has done the timeout of 5 here, which I don't think DeepSeek did. Okay, no, that's all right. At least this time it's told us that it's added a timeout in the comments, which is cool. And yeah, this is catching a sort of very generic exception. So when we have this request exception, there may be more specific exceptions which inherit from this. So this would catch, yeah, most exceptions. But I think the way DeepSeek has done this, I actually quite like, because it's catching these specific exceptions, and then, yeah, if they did happen, it would then go ahead and be like, okay, print this specific error has happened. So, yeah, I've got to give it to DeepSeek for this one. That's pretty cool. It's made it really nice, really straightforward. It's handled the different error types really nicely. Whereas ChatGPT, I mean, yeah, I still think this is fine. This is perfectly usable. But if you want to be really specific about what errors you're catching, yeah, this is pretty cool. So let's go ahead and go into our next section. So what I want to do this time is make it into a class. So let's go back this time, but let's see, make into a class. Okay, here we go. So it's made a class HTTP bin client. That's, yeah, pretty good, straightforward name. It's built my constructor here. It's imported requests. It's done my doc strings quite nicely. I like those. Let's give me the URL here. Okay, so it's used a base URL here. and then put this right at the end. That's pretty neat. So the actual HTTP bin site has sort of different things you can do. There's a /get, there's a /post, there's quite a few. I wonder if it's been trained on that and knows that. I don't know, but yeah, pretty cool. And let's see what it's done. It's made the get request method, or instance method. It's passed in self correctly, that looks good. It's returned none if we get an exception. Yeah, this is pretty cool. I like this. Okay, let's see what it would have done. So it returned the response here if that's fine. However, if any of these guys end up getting triggered, it's going to do the print and then return none down here. So yeah, pretty good consideration. It's done the if dunder name is equal to main, evoke an instance of this class. So yeah, looks good. And then done response is equal to client.makeGetRequest. Yeah, it would have called this and given back that code. Tell you what we'll do. Let's go ahead and just try this. So let's put this down here. And that looks good. I'm just going to hide my terminal again, because yeah, once again, it's showing my IP address. So yeah, that's absolutely fine. I think that's nice, straightforward, kind of usable code. But yeah, that's really good. Let's now try the same with ChatGPT. So let's copy and paste the prompt. Okay, take this. Put this into here. Make into a class. Right. So far, I think DeepSeek has been the better of the two. But let's see how it does. I mean, yeah, that's fine. I think that works nicely. What has it done differently? So it's assuming that this is always going to be passed in at the start here, whereas I think with DeepSeek this was. Let's go quickly check. Yeah, it's passed this as a default parameter here. So yeah, this guy is, I mean, it's okay, except, you know, you're going to have to be passing this in every time. Again, it's kept the sort of fairly generic exception handling here, and just, yeah, done this, return this, or return this here. Yeah, I mean, this is fine, I guess, but I think that's it. It's just okay. It's just fine. It does the job. I still think this is a much better kind of way of doing it. This has done some quite nice, clean code with a kind of nice kind of comments here. I like this. This is cool. I think if I was learning Python from scratch, I would really appreciate these. Whereas this here, like, I guess not doing the comments, I mean, it has given us these features here, which is okay. But yeah, I think that's 1-0 to DeepSeek. I don't know about you guys, but if I was learning this from scratch, yeah, I would much prefer this one here. So yeah, 1-0 to DeepSeek. Let's go ahead and remove this code. And let's go ahead and take a look at number 2. So let's remove this here. Now, for number 2, what I want it to do is I want to test its knowledge on, well, this is a particularly popular question. It's the two-sum question from LeetCode. So we will take this guy here and, okay, ChatGPT, you can go first. Solve the LeetCode question two-sum. If you've not seen this, I would recommend checking it out. It's kind of a cool one. Give that a second to go through here. Okay, now it's given us a nice little summary as well. So the two-sum problem LeetCode requires finding two numbers in an array that add up to a given target. Here's an efficient solution using a hash map or a dictionary in Python, which runs in O of n, so linear time complexity. And this is nicer than it did last time. I feel like the way it's doing the comments with each of these lines is pretty cool. I don't know about you, but the first time I saw two-sum, like, this kind of concept baffled me until I kind of understood it, and then it was like, oh, it's actually quite easy. But this is pretty cool. That's true as well. The problem guarantees one solution. It does. If you look at the brief on LeetCode, it does say that. Yeah, target of 9. This is cool. Let's go ahead and try this. Hitting run, yeah, 0, 1. So it would be 0, 1. Let's go ahead and change it. So 7 is at the back. 0, 3. So 0, 1, 2, 3. Yeah, that's fine. Okay, now let's ask DeepSeek the same question. Here we go. Solve the LeetCode question two-sum. It's taken a second to think. Okay, good start with the. It is, yeah, it's a classic coding interview question. I quite like this. I like the way, like, if I kind of go back here for a second. I mean, this is fine. It just kind of spits it out and shows it. I like the way it does this kind of, like, see how it does these lines here to kind of split it all up? I don't know if that's just me, but I think that's pretty sweet. It gives me a nice example. You can tell it's been trained on the same thing. Look at that, the numbers are the same. 2, 7, 11, 15. I think we had the same here as well. Output of 0, 1 with a nice explanation. I mean, yeah, I think this wins just based on the fact that it gives me this nice explanation as well. It tells us about the same techniques using a hash map or a dictionary. Does it give the time complexity? I don't know. Oh, it does, yeah. O of n. We traverse the list once. Dictionary lookups are 0, 1. Constant time, yeah, it's right. Space complexity, O of n, we have to store all n elements in the dictionary. I don't know if this gave us space complexity, did it? No, we got time complexity. And we got... No, we didn't get space complexity, but we did for this one. I mean, yeah, I don't know, maybe time complexity is more important, I guess. Don't quote me on that. But yeah, we got time complexity and space complexity here. And let's go and check out the code. You know what, I think it's pretty much the same, isn't it? If no solution is found, though the problem guarantees one. Yeah, let's go try it. So let's do this here. Iterate through the array, calculate the complement. Yeah, it's pretty much the same. 0, 1. Again, let's just try and do that same test. Let's put 7 at the end. Make it 17. We're expecting 0, 3. And we get 0, 3. Okay, let's go back to this here. I mean, I think I'm going to give this one to DeepSeek. I like the way it's kind of done this example walkthrough here. I mean, look how cool this is. Start of an empty dictionary. It's gone through what the first iteration would do, the second iteration. This is nice. I think this is really cool. However, we are going to add this here as well. Make it more straightforward. Okay, kind of a common thing you might ask it. Let's see it make it more straightforward. And actually, at the same time, ChatGPT, I'll set this guy off as well. So here's a simplified and straightforward version of the two-sum solution. This version avoids unnecessary explanations and focuses on the core logic. So what's it done differently? We've got seen, that's interesting, that's different. Oh yeah, that's kind of cool. So initially it called this dictionary num to index. I guess, yeah, mapping of what number is here and what index it's at, but I guess just calling it seen is quite cool. But the actual solution, like if you do seen num equals I here, it's the same. So it's called the dictionary something different. And let's see, has it done the comments any different? Dictionary to store numbers on their indices. Not hugely. I mean, give it credit. Like, you can't do a huge amount different to make this super simple. But yeah, that's quite nice. It's chosen to call the dictionary something a bit more kind of human, user-friendly, I guess. Okay, now what's this done? Make it more straightforward. Here's a more concise... right, that's not more straightforward. I mean, unless you love the walrus operator... I don't know about that. I mean, yeah, it's more kind of simpler and stripped down, but... I think the walrus operator actually makes this a bit trickier to understand. I think when I've said make it more straightforward, obviously kind of what I was meaning is like make it easier for a human or someone who's a bit more, newer to coding to understand this. This is kind of taking the approach of like making the code more straightforward, but I don't know. Is that more straightforward? Yeah, feel free to leave us a comment. Which one do you think's better? Personally, like I would kind of put readability of like code, and if like 10 people can understand this, I know from the same 10, if like half the people can understand this but the other half have to go off and figure out what's going on here, then that's not good. Especially like if this runs in O of n and this runs in O of n, but this is easy to understand, then yeah, use this is better. Yeah, I don't know, you know what, DeepSeek, I'm going to give it to this one again. So let's go through to our final one. I'm going to quickly remove all of these here. And I'm now going to ask it to, and this is something I've done a fair bit in the past, just explaining concepts. So I want to figure out, how does recursion work? Okay, explain recursion in Python. Let's set off ChatGPT at the same time. Explain recursion in Python, please. And let's go ahead and see what DeepSeek's going to say. So it's a technique where a function calls itself to solve a problem. Breaks it down into smaller, more manageable subproblems until it reaches a base case. Yeah, which is a condition that stops a recursion. Yeah, absolutely. And it's gone for this here. So it's given me some code. It's given me a base case, a recursive case, example usage here. And let's see. This is nice. It's given me a base case. So when n is 0 or 1, the function returns 1 without further recursion. The recursive case is if n is greater than 1, the function calls itself with n minus 1, like this here. So the factorial of 5 calls factorial of 4, 4 calls 3, 3 calls 2, 2 calls 1. Yeah, then we're at 1, then we got the base case, and yeah, I mean, this bit is perfect. I think this bit kind of nicely explains how it's done. It's also gone for Fibonacci as well. I don't think that's maybe as easy to understand, but I reckon ChatGPT's probably used the same thing. But look at the explanation for this. I mean, yeah, compare the size difference. We've got all of this all the way down to like here. ChatGPT just sort of like couldn't be arsed and it just gave us one line. I mean, yeah, it's fine. I mean, if somebody was like intermediate, I guess they might get this, but if you're like a beginner, then I don't think this tells you an awful lot, really, does it? I mean, yeah, it's told us about the base case, the recursive call. It's done this, but like compare the explanation to this to like this here. That just wins. So I think, is that 3-0 to DeepSeek? Maybe? It has given us this here, so why to use it and when to avoid it. Oh no, it's done it here as well. We've got advantages and disadvantages as well. And a recursion. Oh god, look at that. Yeah, this is cool. This is really, really concise. Now let's try this. I'm going to say explain like I'm 5. So let's run and run. So they should both give us sort of the same rough output, but let's see how it does it. Right, let's go through this together. So we've got a big pile of cookies, and you want to count how many in the pile, but you don't want to count them all at once. You want a helper to do it for you. Okay, pretty straightforward. So you say to your helper, if there's only one cookie, just say 1 and stop. Yeah, pretty cool way of thinking about the base case. I like that. If there's more than one cookie, take one away and ask me again how many are left. This is the recursive case. The helper takes away cookies and asks the same question over and over until there's one cookie left. Then they count back up to give you the answer. I mean, yeah, that's pretty good. I quite like that. That's not too bad. Okay, that took its time, so I had to actually refresh and ask it again a couple of times. It kept telling me that the server was busy, but yeah, I guess that's the drawback of a mega busy site. I don't know. So let's see what it says. We have a big box of Legos, and you want to build a tower. But instead of building the whole tower at once, you build it one Lego at a time. Okay, yeah, pretty, I guess, sort of similar to the cookie analogy, I guess. So you take one Lego and put it down. That's the start of your tower. Now I build the tower the rest of the same way. So you take another one and put it on top of the first one. You keep doing this over and over. You take one, put it on top. It's, I guess, actually, yeah, this bit's kind of, I guess, a bit nicer. So recursion's like building your tower by repeating the same small step over and over until the tower is as tall as you want it to be. It's like a loop, but instead of just doing the same thing, you're building something bigger step by step. And when the tower is done, you stop. That's the end of the recursion. So this is all right, I think. I kind of prefer this one because this at least makes reference to like the base case and the recursive case. I mean, actually, if you were 5, would you understand like, ooh, the recursive case? I don't know. Maybe like this is perhaps a bit more truer for maybe someone who was 5, but this maybe has a bit more detail. So I don't know. Maybe it's a draw in this one. I'm not entirely sure. Maybe leave a comment which one do you think's better, either DeepSeek or ChatGPT. So let's go back to our questions. That is my comparison between ChatGPT and DeepSeek. I must say, for the first two here where the actual code writing had to be done, DeepSeek was brilliant. I thought it was really good. I've been using ChatGPT pretty much since it kind of come out. Not really used DeepSeek a whole lot at all, pretty much until today doing this video. But maybe it's time I switch to this for some of the more kind of mundane stuff I had to do. It's not something I use all the time, but I do tend to use it for sort of really simple boilerplate stuff. And I use it a fair amount in research as well. I think for this one, to be honest, I have to give it to DeepSeek. But what do you guys think? Is the one you prefer over the other? And of course, let me know why. If you think one is much better or one is terrible, let me know why. It's obviously good to have that nice, healthy debate. Cheers for watching, guys, and see you all in the next video.